Hi everyone, this is Chris Eng from Veracode Research. Today we'll be demonstrating TXS-bbspy, a proof-of-concept BlackBerry spyware package developed by Tyler Shields, one of our senior security researchers. TXS-bbspy was developed to illustrate how simple it is to create malicious mobile applications using the handset provider's own APIs. Most consumers aren't aware of the range of information that can be accessed by BlackBerry applications, particularly those granted trusted application status by the user. Let's get started. Tyler has the spyware installed on a dedicated BlackBerry device, and I'll be controlling it remotely to demonstrate some of the capabilities. We'll use a spare Google Voice account to send the text messages required to issue commands to the victim's phone. The spyware will intercept all incoming text messages starting with TXS, which is how we've defined the command and control protocol. The first thing we need to do is tell the spyware how we want to receive information. It's capable of using email, SMS, and HTTP, as well as raw TCP or UDP sockets. We'll send the command TXS EXFIL email to indicate that we want to use email. Next, we need to specify the address of our email account. To do this, we'll send the command txsem:/@gmail.com. We have to use an asterisk instead of the @ because otherwise the BlackBerry will modify the email address. Now that we've told the spyware how we want to receive the data, we can start issuing actual commands. There are two types of commands available to us: dumpers and listeners. Dumpers are one-time data retrieval functions that we can use to read information at the time the command is issued. Listeners are real-time monitoring components that watch for specific activity to occur and send the data out as it becomes available. We'll start with a dumper. We'll send the command txs dump con, which stands for dump contact list. The spyware will send one email for each entry in the victim's contact list. Let's switch over to our Gmail account and wait for the data to arrive. As you can see, we are receiving some emails containing address book entries for Barack Obama, Homer Simpson, and a few other contacts. Let's dump his email now by sending the command txs dump email. Again, the spyware will send one email for each message in his inbox. We'll switch back to Gmail to watch the data come in. You can see here that one of the messages in the inbox contains a subject line of confidential and a message body containing "Here are the secrets." Now let's listen in on the room using the command txs dump mic. This will activate the BlackBerry's built-in microphone for approximately 5 seconds and then send us the recording in AMR format. We could have made the recording time configurable, but this is good enough for a proof of concept. Let's go back to Gmail. Here's the message. It's encoded in base64, so we'll dump it into a file and then decode from the command line. Now we'll play it using QuickTime. Hopefully you could hear that. Okay, now let's try a listener. We'll send the command txs sl out on, which stands for SMS listener outbound on. What this means is that every time the victim sends a text message, we'll get a copy. We'll also send the command txs sl in on, which will do the same for text messages that the victim receives. Now that we've done that, I'm going to use a different phone to send a text message to Tyler's phone and verify that we receive a copy of it in our email. Okay, I've done that. Let's watch our Gmail inbox again. There it is. We can see the origin of the text message as well as the contents. Tyler's going to reply to that message and we'll get a copy of that too. Here it is. You can see that he replied to the SMS that we had previously sent. I'll turn off the SMS listeners now. Let's turn on some more listeners. First, we'll send TXS PHL on, which stands for Phone Listener On. Every time the victim starts or ends a phone call, we'll be notified. We'll also send TXS GL on, which stands for GPS Listener On. This will send us periodic notifications of the victim's current GPS location. The frequency of the GPS updates defaults to once every 10 seconds, but for demonstration purposes, we'll increase the frequency to once every 5 seconds by sending a separate command. Now Tyler is going to get in his car and go for a drive. All of our listeners are enabled, so we'll be able to see not only where Tyler is, but what he's doing on his BlackBerry. For the GPS location updates, we're taking it one step further and piping all the emails through an automated script that will parse out the coordinates in real time and generate a keyhole markup language or KML file. Then we can import the KML file into Google Maps or Google Earth. We'll come back to that shortly. Okay, let's go back to our Gmail inbox. We can see here that Tyler did make a phone call since we started the phone listener a while back. Here's the phone number that he called. If he had a corresponding address book entry, we would see the name of the person that he called as well. We can also see that the call ended at a certain time. We can also see that some of the GPS location updates are beginning to trickle in. So let's fire up Google Earth. We can point Google Earth at our KML file, which is being updated on the fly and being posted on a web server we control. The blue markers are the individual GPS updates we're receiving every 5 seconds. The red line simply interpolates a path between the points. As you can see, Tyler was in a parking lot of some sort, and then he got on the road and just started driving north. If we keep refreshing the link, we'll see additional points being added to the map as Tyler moves around. Looks like he's just driving around a parking lot. Relatively slowly. We can also view this in Google Maps. Now we can take advantage of the map overlay to figure out exactly where on the road Tyler is. Let's switch back to Google Earth and see if we've collected any more GPS data. You can see that we now have 77 data points collected since we first turned on the GPS listener. We can zoom in on the path and figure out where Tyler's final destination is. This concludes our demo. For more information, please refer to our blog post, where there's a link to Tyler's slide deck containing more technical details about the implementation. Thanks for watching.